Okay, this is lesson 1.5, characteristics of logarithmic and exponential equations. So let's take a look at our exponential equation as it sits. So we've been solving same-base equations and non-same-base equations. But we didn't really know what an exponential equation looked like until we see the actual base. So this is our base of our exponential equation. So that means it's our generic formula. So I've got y equals a times b exponent x. So whenever x is the exponent, it's exponential. So that's how come this is called exponential, because x is your exponent. Okay. So what does x represent up here? It can be a rational number, meaning it can be in fraction form. Now, if it's in fraction form, it needs to have brackets. So it can be a rational number. Rational number just means fraction form. Okay? So you could have a fraction exponent. We've already seen those. That gives us a lot of times root signs. Those fraction exponents. Okay. On the left-hand side, well, what does A stand for? Well, we weren't sure till right now. So A actually stands for, let's take that back off there. A stands for the y-intercept. It's got two other names. So the other names it has are initial amount and starting point. Okay, so it's going to be a starting point on your graph. It's an initial amount, meaning starting amount. Initial means starting. And in any generic equation, it's always the y-intercept. Okay? Always, always. Okay. So, on the bottom right, what does B stand for then? B is always our rate of change. It's our base number. So, it is called the rate of change. These are jumping all over. Okay, it's our base. Okay? It's the base of the exponent. It's the part that you usually want to have isolated. Now, in an equation, you don't always see an A value. There's always an A value, but you don't always see it. So if you don't see it, it's always a hiding 1. So that's what this says to us down here. So if the equation is written without an A equals 1. Okay? So that is super important for us to know, because that's its y-intercept. It will always touch the y-axis, no matter what. So now we're going to get into what does a graph look like of this type of equation. And it's got specific characteristics. So here's our characteristics. So we're going to first of all just deal with a y-intercept of 1. So our A value is a 1. And then we're going to just investigate what does the B do to the equation. Okay? So what does B tell us about how the graph's going to look? It tells us quite a few things. So first of all, what we're going to do is we're going to type in our calculators. We're going to try and fill out all of these numbers. So if I want to solve the y, I'm going to go 3 exponents each of those numbers. Okay? So I'll give you a moment to do that. Use the x numbers as the exponent to fill in the y column there. Okay? I'll give you a couple minutes. So we've got the values of our y numbers now. Okay? So when it's -3, it's 1 over 127. Or sorry, just 27. When it's -2 for x, it's at 1/9. -1, 1/3. When the number on the bottom starts to get bigger, your graph is actually increasing. So this is actually going to be something like this. It's kind of going like this, and then it comes over here, and then it comes over here, and then up to there. So you're going to see it taking quite a swoop. Okay? Because its y-intercept is 1. How do we know that? From that and the fact that there's no A value. So it's got to be a hidden 1 there. Okay? So this is what our graph should look like. We've got a y-intercept. Do we have an x-intercept? No, it doesn't touch the x-axis. Well, there's a reason it doesn't touch the x-axis. It's called its horizontal asymptote. Now, an asymptote is a line that a graph will come super close to, but it'll never touch it. Okay? Comes very, very close, but it'll never cross it. So that means exponential do never, ever, ever cross that x-axis. Never, never. So they're always going to go from quadrant 2 to quadrant 1, always. Whether they go up or whether they go down. We're going to investigate that next. So, is this guy increasing or decreasing? How do we know? Well, he read graphs the way we read a book, left to right. So if I look at this guy, on the left-hand side it's low, on the right-hand side it's rising. So that means it's an increasing graph. Okay? X-intercept, never. There will never be one. Okay? Yep.
Can you tell the y-intercept as well as if, like, the a number is positive?
Exactly. So the a number is your y-intercept. So here we don't have one, so it's 0, 1, because you weren't given an a number. So if you're never given an a number, it's always 1. Domain. Are there any boundaries on the left of the x's, the negatives, or the positives of the x's? No, there's no boundaries. The graph goes on the left, and the graph goes on the right. So that means there's no boundaries for negative, no boundaries for positive. So we say no boundaries by saying x is an element of the real. Okay? So no boundaries. Okay, so no boundaries, XCR. Now the range does have a boundary. We're never going below 0 because we can't touch that x-axis. So that means our range will always be y has to be greater than 0. And then comma y-e-r. Okay? So as long as it's above 0, it can be absolutely anything. That's what the y-e-r on the end means. But as long as it stays within that boundary, it can be any type of number. It could be negative, it could be a positive, or sorry, not a negative, but it could be a positive or it could be a fraction. It could be a decimal as long as it's not a negative number. Okay, that's what that's saying. End behavior, that's what quadrants do, the tails of your graph. The tails are the ends of your graph. So it starts in 2 and goes to 1. It'll always be that way. Okay, that never changes. Now, the equation of the asymptote, that's the line it never touches. So it's the x-axis. Well, the x-axis is y equals 0. That's the equation of the asymptote. Okay? The equation of the asymptote, we know it's the x-axis, but we label it like this, y equals 0. So it's always the opposite letter who is equal to 0 on that line. So these guys are going to have an asymptote of what? X equals 0. Okay? All right, let's take a look at the next graph. So the next one now, we've changed the b value. So we had a b value that was bigger than 1. Okay, we had a b value of 3 that time. Well, now what they've done, they flipped it. They made it a b value of 1/3. So what's happening with 1/3? So we're going to go into our list, and we're going to create our list of values again. So everybody get on that list of values. So you're going to notice something similar about the digits. Please fill in the y column again, okay? Give me a minute to do that. Let's see if you guys got the same thing. Did you get 27, 9, 3, 1, 1, 9, 1 over 27? We all got that? Or 1/3 1/9? Okay, thanks. It's just the opposite of what these guys are. It's 1/3, 1/9. Awesome. Okay, let's take a look at what the actual graph looks like then. This is a decreasing graph. So it's going to come up here. Negative 3 is going to be way up at negative 27. We can't see that. But negative 2 is at 9. And then negative 1 is at positive 3. It's got an x-intercept of 1. So it's going to be coming down, and it's going to come along there, but it's never going to touch it. Okay? It's going to come along the x-axis, but it won't touch. So, do we call this an increasing or decreasing function? Decreasing, you bet, because it's going left to right down. So, x-intercepts, we never have them, not applicable. Y-intercept, it's always your a value in your equation. We didn't have one, so it's a digit 1. So, 0, 1 in this case. Domain, what is it always? XER. Range. Y is greater than 0, and then comma y-e-r. We don't say greater than or equal to, it's just greater than. And behavior again, 2 to 1. And equation for asymptote, x equals 0. Y equals 0. No, it's y equals 0. Okay, y equals 0 on the x-axis. Alrighty, let's take a look at the next one. The next one we're going to compare 4 different functions. Are you ready? Clear question? No? Okay. So we're going to now take a look at what the a value does. So what did we notice in the last 2 equations? What did the b value do? It made the graph either go up or down. So the b value controls the up-down. What does the a value control? Well, we know it's the y-intercept. So that means it's going to depend on how high it is on the y-axis. That's what it depends on. So this guy here, we only see a b value. So what is the first one's a value? 1. Good. So this guy's going to be a positive 1. We know it's going to go up. Okay, there's our first graph. Okay, I'm just going to number them. 1, 2, 3, 4. Okay, there's graph 1. So that means that's graph 1. That digit that I just went through, that's 1 on the y-axis. Because he had a 1 for y-intercept. Now the 2, what is the 2 going to do? Well, we're going to have the same flow. It's just going to be a little bit higher. It's going to be over here on positive 2. The 5 is going to be way up. And the 5 will be up here. They've got the same base number, so the shape of their curve will be identical. If they had different bases, the shape of their curve will be different. Now, what do you think the next one's going to do? Lower than 1. Okay, so this guy's going to come way down here and be halfway through. So that he could be at 0.5 there. So we got graph 4, graph 1, graph 2, graph 3. That's the way it goes. You label and name your graphs on the tail end. Okay. What does the a value then do to our exponential graphs? It changes the y-intercept. So it changes the y-intercept. Or the starting amount if it's problem solving for bacteria or something. All right. Next, so now we're going to graph them. But we've got negatives. Well, our a value usually is a negative. So the ones we deal with in dash 1 are always dash 2 are always the positive ones. But they often throw negative a values in there, negative x, y-intercepts, because they want to know if we can transfer what we know into what if it happens to be a negative number. What do you think is going to happen to it? Any ideas, any guesses? Okay, it's going to go down. Where is it going to come from? Okay, it's decreasing, yeah, but where is it going to start from? It's going to start from, okay, I'm going to ask my quadrants. 1, 2, 3, or 4. Which quadrant do you think it starts in? Now, normally we say it's always 2 to 1. That's if A is a positive number. If B is a negative number, A is a negative number, it completely changes our quadrants. It changes us to quadrant 3 and 4. So now, this is what's going to happen to these guys. Now let's take a look at what's going on. So my very first one, we're going to grab the very first one. So I'm going to have the first one coming through like this. There's my first graph. That's negative 1 there. Okay? Now I'm going to go to negative 2. Negative 2 is the next guy going down. Same curve. Negative 5, he's just way lower. Same curve. And where's 0.5? Yeah, he's the top above here. Okay, and that'll be the negative 0.5. So what did it do to our graphs? It gave us a reflection of the x-axis. So everything that was up here flipped and came down here. That's all that happened. So it was an increasing function above, but on the bottom end, it's going to be a decreasing function. Okay? So that's what happens to it. Good to go? Okay? All right, so what does the A value do to it? Well, it gave us a reflection in the x-axis. And then it did the opposite. Okay? So the y-intercepts all became negative values. Okay? So if they change those y-intercepts to negative values, it's just going to give you your reflection. All right, let's take a look and see what all these characteristics are. Now, this stuff down here is the way it's going to be written generically, always. So we need to understand what those parts mean. Okay? So we're going to take everything slow here. So we're going to summarize everything we know about this equation. Okay? A times b exponent x. That's our exponential basic equation. So the y-intercept is always which letter? A or B? It's A. Y-intercept is always A. There is no x-intercept, ever. Ever, ever, never, even if it's a reflection. The x-axis is a horizontal asymptote. Okay, so it's a horizontal asymptote. What do you think your domain is? What's our domain? X is an element of the real. So, we're going to write it officially, and we're going to say x such that x is an element of the real. Then we're going to put it in our curvy braces brackets. That's officially how you would write your domain. The range depends on your A value. Absolutely it does. So if A is greater than 0, so that means if your y-intercept is positive, that's what it means. So if the y-intercept is positive, and the negative one below it is if the y-intercept is negative. Okay, so then what happens? So it wants to know my boundaries on my quadrants, 1, 2, 3, and 4. So if A is greater than 0, it's doing this. So that means my range would then be y greater than 0, and then comma y, e, r. Okay? Now what if it's down below? Like the ones we just discovered, these ones. What if it's in quadrants 3 and 4? Then we say that it has to be less than 0, y, e, r. So that's only if the A value is negative or positive. 99% of the questions we're going to deal with are all positives. It's very rare we have to deal with these negative A values, but we have to know they exist, because on certain diploma questions, they will ask you to adapt your knowledge, which means we need to understand what the reflection is going to do in the bottom half of the quadrants. Yeah, it does, yeah. So these would have in the front, so these would be officially braces y such that. Braces y such that. And then the braces at the end. Okay, so that's the official notation for that. Alrighty. Now, what happens with A and B and if they're decreasing? So what we're actually going to do is we're going to draw the graphs of these on the next page on these graphs, and then we're going to fill in the information. Okay, we're actually going to sketch the graphs. So, let's jump to our graphs first. So we're sketching each scenario. So here's scenario 1, where A is greater than 1 and B is greater than 1. Okay, that's scenario 1 on the other side. Greater than 0, pardon me. Okay. So, first scenario, it's going to be an increase. Quadrant 2 to quadrant 1. That's what that's going to give us. Now, which one tells us up or down? The B tells us it's going up because the number is greater than 1. The A value tells us the y-intercept is positive. So it tells us two things. Y-intercept is positive and it's going up. Okay? We're going to take a look at situation 2. Situation 2 tells us that A is greater than 0, but B is not. B is between 0 and 1. That's what this notation here means. This is between. Okay? So, first part, A greater than 0, let's say we have a positive y-intercept. Okay, so I have a positive y-intercept, so I know I'm on the top half of my graph. But because it's between 0 and 1, this tells me it's going down. So if it's going down, I'm going to have a graph doing that. Okay? Up versus down. Now we're going to look at situation 3. Situation 3 tells us that A is less than 0. So that means our y-intercept is a negative number. And then it tells us B is greater than 1. So that means it's increasing if A is greater than 1. But is A greater than 0 here? No. So it's going to be the opposite. So B bigger than 1 here is actually going to go down. It's going to be a decrease. Okay? The reason it's a decrease is because it's the opposite, because the A is a negative y-intercept. That's the reason. So it's the reflection of the one above. So because it's the reflection, it's going to do that. It's going to go down to the right on the bottom half of your graph. Okay? It's going down to the right. Situation 4 is the reflection of the one above, situation 2. So A less than 0, meaning we have a y-intercept that's negative, but then we've got B between 0 and 1. So if A was bigger than 0, that means the graph would go down, but it's opposite. So now it's going to go up. So it's going to do this. It's going to rise. Okay? That's how those ones go. So, right above each other, we have what we call opposite operations. Well, we deal with graphs as well. So because of that, we would say graph 1 and 3 are reflections. Okay, so since they're reflections, we call them inverse. Same with graph 2 and 4. They're a reflection, so they're called inverse graphs. Okay? So they are opposite inverse graphs. By inverse, what it means is they've switched the x and y values. And if they've switched the x and y values, that's why it's in different quadrants. Okay? That's what's going on there. So now we're going to go back to our little charts here. We're going to fill out the bottom here. So looking at what each of those graphs did, we're now going to say the graph rises or increases. And then the next one is going to be decrease. And then decrease. And then increase. Now, if we go back to just the basics in quadrants 1 and 2, and if I compare the B values, okay, we're just going to compare B values. So that means up and down stuff. So let's say when the B value is 1, or greater than 1, that means he's going up. But what happens when that B value gets bigger? What if I put a 3 or a 4 or a 5 there? Well, let's take a look on our calculators what actually happens. So, We're going to go to our y equals, clear out what you've got in there, and now we're going to type in, let's just go with 2 exponent x. 2 is bigger than 1, so let's just go 2 exponent x and see what it looks like. Then what I'm going to do is I'm going to go down to the next one, and I'm going to make the number 2 go even bigger. I'm going to go 5. 5 exponent x. Okay? Now, over on the left-hand side, over here, I'm going to, that thing's twitching there, you see? I'm going to make it be in different calculators. You can change the colors in your graphs or whatever. This one, I can just change the thickness of my line. So what I'm going to do is the first one's going to be a normal size line. The second one will be thicker. That way you can tell which line is being graphed first. So both of these, what we're going to compare now, is we're going to compare how steep the graph goes, and if they get closer to the x-axis or closer to the y-axis. So let's hit graph and find out. So what do you think happened there? So our first graph, y equals 2x, he's right here on the right. The next one, 5 to the x, is over on the left. What do you notice? Yes. The second one is steeper. So we're going to make a general statement saying that as b increases, the curve gets steeper. So, the curve gets steeper as b increases, which means the graph gets closer to the y-axis. That's what's actually happening. The graph's getting closer to the y-axis. It's steeper. When it's between 0 and 1, the curve gets steeper as b does what? Well, let's check it out. We'll change our b values now to fractions. So in here, instead of 2, I'm going to put 0.5. 0.5 exponent x. And then I'm going to take a different one. Let's go with 0.25 exponent x. Okay, which one's bigger? 0.5 or 0.25? Well, if we think who's closer. We're doing this, and I've got 0.25 or 0.5. Which one is a bigger number? 0.5 is a bigger number. We know they both have a y-intercept of 1 because they don't have an a value. So their a value means they're crossing at 1 at the same place. So one of them is going to be closer to the y-axis. One of them is going to be farther away. Well, let's see which one does it. So, who's closest to the y-axis? 0.25 is closer. So the smaller the b number is, the closer it gets to x. Or sorry, closer it gets to y. The bigger the b number, the closer it gets to the x-axis and it spreads the curve. Yeah. I know, they look really close to the x-axis, but they honestly will never touch. Yeah. It just looks like it because of our boundaries in our window. Okay? All right. Let's get rid of the graph there for a minute. We're just going to move on, and we're going to answer that question. So, as b, so this guy here, the curve gets steeper if it's closer to the y-axis. Again, it's closer to the y-axis with a smaller number. Okay, so it's closer to the y-axis with a smaller b number. So if we increase the b number, it's getting closer to the x-axis. I'm going to show you what that means. So these guys right here, so this guy here, here's our first one, okay? Then our next one, 0.25, was rated here and then crossed and went through. Well, the reason that 0.5 is out here and 0.25 is there is because as b gets bigger, the curve is going to continually get closer to the x-axis. Okay, so it's spreading its wideness of the curve is what's happening. Okay, so that's only when b is between 0 and 1. And it gets more defined as we use these graphs more, okay? So don't fret if you're just still a little bit like, what the heck is she talking about? It's going to start making sense when we're working with it, okay? So let's take a look at these ones. So now we're going to switch over and we're going to look at how does it compare to a log graph then? So these are exponential graphs. How do we compare it to a log graph? Well, we're missing the a value up here because there's always an a value and a b value in log as well. The a value sits in front of the word log, okay, if there is one. And it's the coefficient. Now, the coefficient of log, it will tell you up or down according to whether it's positive or negative. And that's if the base value is greater than 1. So, if the base is greater than 1, then the a value controls increase or decrease, so up or down. Okay, so if the base is greater than 1, then the a value in front, the coefficient, is going to control whether the graph goes up or down. Now, there's always something that they have a generic statement they state with our log equation. They always say that x has to be greater than 0. It's going to be a positive, so that means our argument number, the argument is always positive. We never deal with negative arguments. -1 all day, not us. The base number can never be 1. So the base can never equal 1. It's got to be either bigger than 1 or smaller than 1. Okay? And if we don't see a base, the hidden base is what?
10.
Right. The hidden base is always 10 if we don't see one. So, we are going to put our log graph in the calculator. So, if you do not have log base, if you've got log base, you're going to graph that. If you don't, in your y equals, you're going to type in log x in brackets divided by log 2 in brackets. That's how you have to type it in. So I'm going to type it in my calculator, the way you have to type it in, so that we can see it. So I'm going to my y equals, figure out what I've got in there. Now I'm going to put my log equation in. So I'm going to have log of x, close my bracket, divide by log of, what's my number? 2. Close my bracket. Now I'm going to see what my graph does. Oh, where did you notice the graph ended up? Quadrant 1 and 4. So it's completely different from what happens up there. So we have a graph doing this now. Okay, it's always going to be quadrants 4 and quadrants 1 for a log graph. Now, for increase or decrease, it will depend on whether the a value in front is positive or negative. So this guy had an a value, it's hiding, it's positive 1. So because the a value here is a positive 1, it's an up graph, it's increasing. Okay? So it's increasing. Now, if the a value was a negative, it would decrease. So now we're going to jump in and put a negative. Yes. So grab your calculator again. We're going to now put it as a negative to see what happens. And I think that's on the top of the next page. Oh, we're dealing with b values first. I'm not going to change the a values yet. We're going to change a values on page 23. Okay, we're going to change b values instead. So let's go to our b values first. So these are our bases of our logs. We want to see the difference of them. Okay? So I have log 2 in. Log base 2 of x was going up. Do you notice each one of these has an a value that's positive? Yes? Good. Because they're all hidden positive 1s in there. Okay, for all of these are hidden positive ones, so A is greater than 0 here. Okay, which means it should go up, maybe. Let's check it out. So, if I graph the very first one, it's going to do this. And I'm going to number the graphs again. 1, 2, 3, and 4. So here's graph 1. And our x-intercept here is at 1, 0. The x-intercept will always be at 1, 0 for dash 2. We never have to calculate or find y-intercepts. X-intercepts. So our only x-intercept ever is a 1. If you get asked a trick question that says, what is the x-intercept of this nasty looking log? 1. Okay? It's always 1 for us. All right. Graph 2. Any guesses? Do you think it'll be higher or lower? Do you think it's a little bit higher? Well, you're actually right. There's graph 2. It also goes through positive 1. They will always go through the same x-intercept. Now we're going to look at the fraction bases. Now, graph 3 and graph 4, they have fraction bases. Any guesses? They're going to go down. So, here's one there. That is graph 3. So that's 0.5. Which decimal is bigger, 0.5 or 0.3 repeating? Who's bigger, 0.5 or 0.3 repeating? 0.5. Now, if we're on the lower end, going down, so if I were to count on the y-axis, who would be closer to the x-axis, 0.5 or 0.3 repeating? Closer to the x-axis? Because remember, you're going to be at 0, and then you count from 0 up, or you count from 0 down. So if you're starting at 0, which number will be closer to the x-axis? The smaller decimal number, so the 0.3 repeating number is closer. So it's going to come through, and it'll be closer in here. It's going to be closer to the x-axis. Okay? And it's because on the y-axis here, 0.3 repeating and 0.5, that's the order they go in. Okay? Even though they're negative values in the y-axis. Right? If you just take them as positive values, who's closer to the x? Or negative values, doesn't matter. Who's closer to the x will be 0.3 repeating. Okay? So, if the a value is equal to 1, what can we guess about them? Well, it controls increase and decrease. Okay, after with these statements, we're going to stop there today. Then it says, if a equals 1, or greater than 1, it also controls how close to the x-axis the graph is. Okay, so that's if A is this and B. What does B do? Well, if A is that, B controls how close. Okay, if A is this, B controls. So instead of it also, B also controls. So the it is B I'm talking about. B also controls how steep to the x-axis the graph is. Okay, so that's what it's going to control. Okay, once you've got that written down, yes, you can pack up. Please don't fly now. Please keep your phones off. Okay, got a few minutes to take a look and do some graphing on your own. So, what did we find out about the x-intercept? Well, we know it's always at 1 and 0. The y-intercept, we never have one. Okay, because we have a vertical asymptote. The vertical asymptote is the y-axis, which makes it x equals 0. That's the equation. Domain, well, we have a boundary on y this time, or yes, on x, pardon me. because this is our x, this is y positive, y negative. Well, the graph goes in the positives and the negative y's, but it does not go past in the negative x's. So therefore, we've got a domain boundary. So the domain boundary now is x greater than 0, xpr. And then the range becomes ypr. So hopefully you're noticing that these are exactly the opposite of what we found with exponential graphs. So now what we're going to do is we're going to find out what does that coefficient of a do. Now, we already talked about what b does. B can control it going up and down. But if we make our b value a fraction or a smaller number, then it actually controls the up and down part if the a number is the same. So what that means is this. Our a values, what they do, if our base number, so looking at our base here, if our base a is greater than 0, okay, or b, pardon me, base b is greater than 1. B has to be greater than 1. So since b is greater than 1, then a controls up or down. Controls with 1L. Controls. So when we take a look at these graphs, we're going to graph absolutely all 4 of them, as you have had time to do. So what we're going to notice is we're going to have the ones going up. So we've got one up there, we've got another one a bit lower. So let's go through the same x-axis. So this one has, we number the equations, 1, 2, 3, and 4 again. So equation 2 is higher than equation 1. Now, why do you think that is? Here's our x-intercept. Back over here. Okay, so now we're going to do graph 3 and 4. So when you notice graph 3 and 4, one of them was really close to the x-axis, and one was way down. So again, they all have to go through the same x-intercept, positive 1 and 0. So we're going to get graph 4 being closest to the x and graph 3 being furthest away. And let's take a look at the numbers in front and see if we can get a generalization about this. So if the a value, so if the a is greater than 0, the graph goes up. If a is less than 0, the graph goes down. Okay? Now, the digit in front also tells you how far away from the x-axis they are. The larger the digit, the farther away from the x-axis, which is why the negative 0.5 is much closer to the x-axis than the negative 2. Because negative 0.5 is closer to 0. Okay, so let's make some generalizations after we've graphed them. So we were supposed to graph all 4 situations. As I had shown you before, we're graphing all 4 of these situations down here. Okay? So let's take a look at what you came up with. So for graph 1, we have a is greater than 0. And b is greater than 1. So it's going to increase. And again, it's going to go through positive 1. Graph 2, however, a is greater than 0, but the b value is between 1 and 0. So this means between. So the a value is greater than 0, but the b value is between 0 and 1. Well, what happens then? Then it goes down, it decreases. If we look at situation 3, now we've got negative a values. So a is less than 0, which means it's got to be negative. Okay, so if a is negative and then b is greater than 1, we noticed it was exactly the opposite of the one above it. It's going to go down. Okay, it's going to be a decrease. Okay, so that guy is going to decrease. But if A is less than 0, again, a negative. For situation 4 here, B is between 0 and 1. This is going to do the exact opposite. A double negative will make it increase. So this guy is going to increase. So looking at each of those, if we were to compare graph 1 and 3, graph 1 and 3 are reflections of each other. Same, a reflection in the x-axis, that is. Same as graph 2 and 4. They are also a reflection in the x-axis. Now, what created the reflection? Well, in this case, on the right-hand side, what created the reflection was changing the A value because the B value didn't change. On the right-hand side, it was also changing the A value. Okay, so we were dealing with changing A values. Okay, so let's fill in our summary chart here. So, an x-intercept. Well, do we ever have an x-intercept? Always, and it's always positive 1. So 1, 0. Our domain, x must be greater than 0, XER. The y-axis is a vertical asymptote with the equation x equals 0. There is no y-intercept, and the range is YER. So as we know, this is exactly the opposite of what we saw. So the next one needs to go increase, decrease, decrease, increase. Okay, check your work. And again, those are just these 4 graphs we graphed. Okay? Now, switching gears, this is our summary page of basically what happens with our graphs. Okay? Now, if B is greater than 0, but it's not equal to 1, so basically, your B value is greater than 1. So B value is greater than 1. This is B greater than 1. Okay, then the A value affects up or down. But if the B value is between 0 and 1, the A values are going to be opposite. Okay. One last summary chart. Let's see if we can put it all together. So, this is exponential, and as we know, this is a log graph. So let's fill in our exponential. Domain, XER. Range, y greater than 0. X-intercept, none. Never, never. Y-intercept, 0, 1. Or it is the A value for exponential. And the equation of the asymptote is y equals 0 because it's the x-axis. The exact opposite is happening below. So, domain, we have a domain boundary. So we're going to notice that these are exact opposites. So it's going to be greater than 0, YER. Yes, we have an x-intercept. This one is always at 1, 0. The y-intercept, none, never, never. And then x equals 0 is our asymptote, and it's the y-axis. So what do we know about them? They are inverse. They are inverse functions, which means they are reflections and opposite functions. Okay, so they are opposite functions, and again, that's if A equals 1. Now we're going to take a look at BC. Does BC have a inverse? Yes, it does. So we're going to see a reflection in the dotted line. The same thing also happens with exponential equations of y equals a times b dx. This would also be y equals a log base b of x. That is similar to that, and that is similar to that. Okay? That's what we're used to seeing. The last thing we're going to do is we're going to match an equation to its graph. So if we're going to match an equation to its graph, there's a couple things we do. The first one is we find the A value. We find the y-intercept. Now this is dealing with exponential equations. So dealing with exponentials, you do start with your y-intercept. So I'm going to look at all the y-intercepts here. My y-intercept here is a 4. My y-intercept here is a 3. Over here I have a 4, and over here I have a 2. So the number 2 and 3 should be easy to match for us. So if we look at our equations, y equals a times b to the x. The number who is our y-intercept is always the a value. So those are the numbers I'm checking right there. So when I take a look, that means that the graph with a 2 is this one. So graph 4 is going to match here, or this guy matches graph A. Then if I take a look, this guy number 3, number 1 here is going to be C. Okay, but then I've got 2 with 4s. I've got a 4 here and a 4 here. So now I have to see if I have an increasing and up graph or a decreasing down graph. So this guy is an increase graph. This guy here is a decrease graph. So if we're looking at increase and decrease, we're looking at that b value. So the b value, if it's an increase, b has to be greater than 1. And if it's a decrease, b has to be between 0 and 1. So meaning it's fraction or decimal. So if I take a look, here's my decimal. So my decimal is going to match d. So graph, or number 3 matches graph d. Process of elimination, number 2 matches b, because these guys are increasing. So number 2 matches b. Okay. We're going to do the same thing on the next page. You had some time to look at these, so I'm just going to put the numbers up. Now, these ones are a little bit different, but you did have to estimate their y-intercept. So we've got 3 increasing functions and 1 decreasing function. So the one that's easiest to find should be our decreasing function. So I'm looking for a b value of a fraction. There's our decreasing function. So decreasing function is going to match g. So g of x is decreasing. So this guy is our g of x. All right, now we've got every other one has a different y-intercept. This is a low y-intercept. This has a middle y-intercept. This has a high y-intercept. So I'm looking at numbers that are going to go from small to big. So I've got 0.5 for a y-intercept here. I've got a 3 here, and I've got a 2 here. So 0.5 is going to be my shortest one. So that's going to be this guy, f of x. Hopefully you match the same one. And if you take a look over on the left-hand side, the highest one is our largest, which is h of x. And then k of x is going to be the middle one. Okay? So make sure you've matched all of those. And if they numbered them, if it was a multiple choice question, and they said put them in order, in this order from F, G, H, and K. So if you had to do F, G, H, and K in order and in a numeric response box, you would match the digits that they matched. So for example, F matched 4, so I would put a 4 in this box. G matched 2, I'd put a 2 in that box. H was 1 and K was 3. So that would be my numeric response answer. Okay? So that is a possibility of the type of question you could see. We have one more matching page. Hopefully you matched it correctly. So again, these are exponential graphs for matching. So we have an increasing function and a decreasing function. Graph 1 is increase. Graph 2 is a decrease. We always read our graphs from left to right, so going down. Now, it's talking about graph 1. It's talking about the value of b. Well, if it's an increasing function, b has to be greater than 1. So our answer has to be d. A decreasing function, the answer would be b here. This one here is a decrease. Okay? All right, check your work. Make sure you've matched everything up correctly. This concludes lesson 1.5.